Hello and welcome everybody to the day 5 of our Smart 25 Days Challenge. So, today we are going to make a lottery smart contract in which a few users can participate and one of them would be awarded all the prize money. Okay, so what happens is a user participates and we will specify a minimum participation fee that he needs to participate with the minimum that amount of ether, and after that we are going to make a function which will pick the winner, and all the money of that smart contract which will be collected by the participants would be transferred to that winner's account. So let us see how we are going to make it. So first of all, we need to open our Remix IDE and then just click on uh, new file, and in the contracts, just we are going to make a file dot file. Okay. So first of all, we need to understand what are our requirements and how we are going to proceed it. So we'll follow the same procedure which we have followed till now. And that is, first of all, we need to think about the state variables. Okay. So in this lottery smart contract, we can think of it that in the real world scenario also, we need some owner or some manager which can manage the functioning of this lottery. Okay, so how this lottery functions, and he would be responsible for picking up the winner. Okay, so he has some control. So we first of all need a manager. Okay, so the state variable is a manager, and we also need to keep track of all the participants. Okay, so who has participated and how many participants have participated, so their addresses, so we need to keep track of them also. So for that, uh, just now I will show you. Yes, so you can see this is the smart contract which we are gonna make, and I will show you step by step and how to approach this problem. So first of all, we need to identify the requirements. Okay, then we need to define our functions. Okay, so in a lottery what can be the functions. Okay, in a lottery you can say ki we need someone that we need a function to participate. Okay, so to enter the lottery, there we need a function to enter the lottery. Okay, we need a function to pick up the winner. Okay, we need the function which can pick up the winners, and similarly we need now we will see the use of one more thing which I'm going to introduce today itself, that is modifiers. Okay, so we'll see the use of modifiers and how they can be used, and other functions. I don't think we need any more functions, but we can, for the transparency purpose or for so that other users also may know who has participated and how many participants are there. So we can make a function for getting the participants. Okay, so we can make a function called get participants or get players, something called that. So let us see how we are gonna proceeded. So first of all, the first line is always the license identifier, PDX identifier, and then solidity compiler version, that it would, this code be compatible with the compiler version above this. Okay. Mhm. Okay. Simple. And now we'll first declare that we are going to make a contract. Okay, with the name lottery. Okay, and this we are going to write our code. So first of all, we are going to declare the state variables that are manager, and a array which will contain all the addresses. Okay. Uh, so we are declaring that the data type of this array is address. Then it is it contains payable addresses. Okay. I have told you what is payable. Okay. In the previous videos. So will be containing payable addresses, and switchability can be public layers. Let's call this layers or participants, whatever you like. Now, for defining who, so now after creating a constructor, we'll proceed further and we will start by creating our functions. Okay. So first function can be to enter the lottery. Okay. Function enter, and in this function we don't need any parameters. It is simply public and payable, because this function will receive some ether. Okay, so that's why we have declared it payable. Okay, so because while someone is calling this enter function, he needs to send some minimum amount of ether, which we will specify here only. Message dot value, and that should be greater than 1 ether. Okay, simple. And if this is true, this condition, then the conditions or the code below this require condition gets executed. Otherwise, the error message would be uh, insufficient funds. Funds to parties. Hmm. So this is what this is the minimum required fee. Then we'll proceed, and what we'll do is if the condition is true, we'll say place dot push. Okay. Then push this the address. Okay, which is calling this enter function into the players array, and this address should be payable. Because if we will not declare this as payable, so what we are doing it here is we are making this message dot sender as payable. If we will not do that, then we will not be able to send some ether or receive some ether from this address. Okay, so we want this address to be able to send us some ether, so we have made this function as payable, and we in the future we want that we should also be able to pay this address something. So we have made it payable, and then we'll be adding this to our this players array. Okay. So this function is now complete, and now lottery smart contract. Okay. So private, then we want this function to be private because we don't want anyone from outside to access this. Okay. So view, because it is not changing the state variables, turns what it returns, it will return a unit 256. Okay, then we'll write the code. And if you remember, I have told you how we generally generate a random number in Solidity, and we are going to do it the same way here. Return 256. Then we are going to use kcat 256 AVI dot encode tag, and we are going to use block dot timestamp and this the length of the array layers dot length length. Okay, you can take any values, any parameters which you may like, any arguments, but we have taken these two. Okay, so with the help of these we are going to generate our random number, but it is not yet complete, and I'm going to show you how we are going to. So what we are going to do is just see. Okay, I will first make it in a simple manner, and then I will show you how we are going to use modifiers and what are modifiers. Okay, so first let us see in a very simple way how we can do it. Okay, so we require sys.sender equals to. Okay, so we require that this function, this specific function, pick winner, should be called by manager only. Okay, and we'll say if this is not true, then only the manager can call this function. That's then we will do one more thing, that is we require yes dot length, what place dot length to be greater than 0, that this array should contain at least some addresses. Okay, and this is if the length is not greater than 0, then we can say no player has participated. Okay, simple. So this is also a required condition. Then we are going to select our winner, and how we are going to do that is we will select the index of that address from this array. Okay, this players array, we are going to select that and address, and how we are going to do it is we have generated a random number. Okay, and now we are going to do the mod of that by players dot length. So you may ask why we are doing it. Okay, so what is the use of doing the mod of this random number with place.length? So what it does, it ensures that what it ensures is that the index which we are going to generate by doing the mod of this random number which we get from here with the place.length, it ensures that the index is only lower or than the total number of players in this array. Okay, so if to make it more clear, if I give you the example, say if I give you the array with some numbers. Okay, 4 say. So what is the length of this array? This is 1, 2, 3, and 4. Okay, so and the index which it contains is 0th, 1st, 2nd, and 3rd. So uh, because we start the counting from 0th index, so what we get here is for a length of 4, we have 3 indexes, okay, from 0 to 3. And if I give do the mod of this array with 4, okay, so what it ensures is that the say if I give you any random array, and if I give you that you have to do the mod of that array by the, and for that very large number, say you have got a number called as any number you can take 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And if you do the mod of this by 4, okay, so what it will give you, either the remainder will be 0, or it can be 1, it can be 2, or it can be 3. It cannot be greater than 3. Okay, it cannot be 4, because if it becomes 4, it already becomes 0. This is the basic principle of modding. Okay, so how we do the mod, this this ensures that you take any random, any large value you can, and after modding that with the length of the array, what you ensure is that it always gives you the numbers between 0, 1, 2, 3, the up to the length of that array, just one before this. And we need just one before this because there is no index 4, because indexing starts from 0. So now it will have index 4 when the length will be 5. So for our case, in the initial case, we'll mod any large value by the length of the array, and we will ensure that the outcome, the result, is only up till the indexes of that array. So this that is why we are doing the mod of this to find the index. We are doing the mod of this random number by the place.length. I hope it makes it clear. If you have any doubts, then you can ask it in the comment section. Okay, so now let us proceed further. Okay, so now what we are going to do is, so we have generated the random number, we have written the pick winner function. Okay, so this winner function is now almost complete, and we need to do one more thing. After picking up the winner, we need to ensure that the amount that he has won goes to his account. Okay, so from the players array index dot, we are using the transfer function of the table. Okay, address this dot, no, this dot be what it does it uh, what it does is this the address which will be stored at this index in the players array gets the amount which is stored in address dot, the address this dot balance is the address of this smart contract. Okay, I have told you before also. If you have any difficulty in understanding these things, you can go through my previous videos. Okay, so after that we want this to get renewed. We want to play this game again, so we want that this array should be emptied. Okay, so all the participants should get eliminated from this array. So what we are doing is we are creating a new array. We are assigning these players uh, to a new array. Okay, this variable a new to a new array, and we are declaring it by using the new keyword. Okay, new address table. And while when we declare a array by using, so now we can just deploy it. Okay, so first of all we'll compile it and then we'll deploy it. See, we have deployed it, and now any user can enter this lottery with some amount of ether, say 2, and mm, some other also. So say if this user wants to pick up the winner, what will happen? Let us see. Okay, so pick winner. So it will not get executed, and it is showing only the manager can call this function. That is what we wanted. Okay, so only the manager can call this function. So the it makes it very clear that yes, it's working fine. And what we can do is now we will try by using the manager's account, picking up the, and we can see who is the manager. Okay, this address is the manager. Anyone can call, anyone can see. Okay, so who is the manager? So this makes it very transparent, and the players can call. Okay, check the array that at 0th index who has participated. So this address. So if someone wants to check at second, then you can, but I will show you why this is not a good practice and why we can make a get players function to get the players. Okay, so first of all, first reason is that it is not showing us all the participants in a one go. What it is doing is it is taking from us the index, and then it is providing ki, at this index this address is stored. So third. So at third, there is no player. Okay. At fourth index, there is no player. So it should not return anything. है ना? So it is not even giving us any actual error ki why it's not being executed. At index 1, it should show the correct value. At index 0, it should show. But yeah, at index 0 and 1, it's showing only. But at 2 also, it is showing the same value, which should not be the case. And so now by using the manager's account, we can pick up the winner, and we'll see. Yes, the winner has been picked up, and it has, mm, you can see it has executed properly, and the balance of the smart contract has become 0. And someone must have got the money. See, this account has received the amount. This has won. So now we can make one more function to get the players. Okay. So function which will return this players array only. Okay, so this will return the whole array. Public, and this only new, and it will returns if it returns this address and label. Okay, see, address payable, and where we wanted it to be in the memory only, not in the storage. Okay, so if you have any confusion between memory and storage keywords, you can watch my previous videos where I have explained them in detail. Yes. So mm, let us now compile it. Let's refresh this too and deploy it. See, we have got a get players function. Okay, and now you can see anyone can participate. And okay, so why so now we'll see the use of modifiers and how we can use them. Okay, so you saw just now that this require condition is working properly fine and only the manager can call this function. But we can do it in a better way, and that way is by using a modifier. Okay, and what is a modifier? So to make it very clear, what are modifiers in Solidity? Modifiers in Solidity are a way to add reusable code that can modify the behavior of functions or or enforce certain conditions. Okay, so a modifier is defined using a modifier keyword followed by a name and a code block. Okay, so I have given this example here also. You can go through it. So I am going to show it to you how we can use a modifier here in the code. So let's call our modifier as restrict. Okay, modifier restrict, and then we'll specify the condition. Okay, that we are require message dot sender to be the manager only. And then we will say if it's not true, then only the manager, just this condition only, and for this. And then what happens is after specifying this required condition, we'll use this underscore sign, and I'll tell you what this means. So we can now remove or comment out this, and we just need to add this restrict here. So this modifier is now in the working condition. What it has done is now when we'll execute the pick winner, so as we have used this restrict modifier here, what it will do is this condition would be checked, and after this condition, the code, this function, the code of this function would be placed here in place of this underscore. So what it does is it checks this same condition, but it places this function without this condition. You can assume that this condition is not at all here. Okay, so this is the code, and this modifier this places this code, this pick winner code, because we have used this keyword here, so it understands that okay, and this modifier places this code here and then checks for the for the condition. Okay, so what is the use of this modifier, you may ask. The other way was also correct. So the use of this modifier is reusability. Okay, we have once created this modifier and we can use it again and again to check the same condition if we may require. Okay, so that's it, and we can check this will work in the similar manner. Compile and then deploy. Then also it will work in the same manner. So that's it from my side. If you have any confusion, then you may ask in the comment section, and thank you.